Hello, everybody. How's everybody doing today? Everybody had a great lunch? Yeah. All right, to get us started, how many of you are currently building agents in this room? Raise your hands. Awesome. And how many of you are using the usage data, the feedback, and the completions that you're getting through those agents to continuously update the models inside of that agent? Okay, like about 5% of the population. So all of you are building agents, but most people are not really customizing those agents. And that's really going to be the core of this presentation. My name is Santiago. I work at NVIDIA. And today I'm going to tell you about how we build data flywheels for agents. And we're going to show you that by going over some of the agents that we've built internally at NVIDIA. So if you've heard Jensen speak about agents, the way we see and we discuss about agents inside of NVIDIA is all about like digital employees. We think they're digital employees. And initially they were built as RAG systems, but now they have the ability to plan, to use tools, and have become more complex. The challenge with new employees is that for them to really be able to contribute, you have to be able to onboard them effectively, and especially they have to have the ability to continuously learn on the job. And that is a problem that is not currently solved. So today's presentation is going to be all about how do we help these agents to continuously learn. The chatbot that we're going to be talking about is NVIDIA's Infobot. You can think about this chatbot as like an employee copilot that we build internally. And this agent essentially helps employees ask questions about anything that they might want. Any questions that they have about the new products that we're launching, their benefits, HR questions, or even financials about the company. Every employee has access to this chatbot, and they can go in and use it as a copilot for effective onboarding. When we click through it, this is sort of the architecture. And many of you might recognize this architecture. This is essentially a mixtures of agents architecture. So the user has access to this client that I was just showing, but the first task of the architecture is we have an LLM router or like an agent router that has to classify the initial query that comes through, and then it has to select one of the many experts that will answer that user query. And in fact, if you see each one of those experts at the end is a RAG-like tool that essentially has the ability to hit some knowledge bases, it can retrieve chunks, it can generate citations, and then provide a very accurate answer back to the user. And of course, the team keeps adding more and more experts as new skills are added to the chatbot. The challenge with one of these architectures is that every single one of those experts can have up to 7 error sources as part of their node. And so if you want to teach this employee to new skills and you want to debug how it's performing, it's actually quite onerous and challenging to do so. So the framework that we use internally at NVIDIA is called MAPE. It's a framework that comes from control theory, which is used and focuses on self-regulating systems that continuously maintain performance. And essentially, what we talk about is, first, you want to monitor, which is have the ability to collect real-time data and performance errors. Second, you want to analyze. You want to identify patterns, diagnose failures, detect trends, plan, determine corrective actions, and then execute, apply those optimizations. Let's start by what do we use to do the user monitoring feedback. So this is a sample of how we collect the feedback from our users. Of course, like any chatbot, we have like a binary solution, thumbs up, thumbs down. But the key part is that we actually ask for very specific error types. This is probably commonplace, but you want to be able to drive down attribution. Another key thing in the enterprise is that you probably want to be asking for consent. PII is very sensitive inside of organizations, so that's something that we control for. Now, the challenge, once you start trying to collect that feedback and use that usage data for customization, is that there's very low participation. In fact, of all of the completions that we see through, we only get about 5% feedback. And out of that 5%, 70% of that feedback is negative. There's very much a negative bias. A lot of the times, you don't know if the agent is performing correctly unless you look at implicit signals of reward, like, for example, downloads, shares, copies, et cetera, et cetera. And as I mentioned, one of the key challenges of being able to leverage user feedback is this notion of private information. You have to be very mindful about that. So our recommendations are, when you are trying to leverage user feedback to teach your agent to perform, you gotta first find very intuitive, the feedback mechanism. Binary is probably not going to get you along the way. You want to have more detailed way of collecting that feedback. You will want to make sure that you are complying with data privacy, so PII removal is something you have to think about. Capturing implicit signals. Are you instrumenting your application well? Are you capturing conversion events like downloads and so on, downloads, saves, and shares? And then, of course, you want to balance the feedback collection. There's ways of serving the users inside of the application so that they're not always you're not always collecting feedback the same way. And most importantly, you want to have real-time pipelines, which allow you to process quickly the feedback and categorize it so that you can accelerate your process. The second part is where you get into root cause analysis. And as I was mentioning, every single one of these RAG pipelines or experts requires seven different parts that we need to analyze. And this is a major pain in the for all of us at NVIDIA. In fact, the team that was building this agent had 2 full-time employees going through all of the requests that we were going through. So the first step that we discovered on how we could optimize this process is to try to use LLMs to help us do this error classification. So as part of the pipeline that I will discuss a little bit later, we essentially are using LLM as judge to help us classify the errors that are coming through and get predictions for it so that we can accelerate the human in the loop experience for the humans, reviewers of the annotations. To give you a sense for what type of errors we are encountering, you can see a question at the top. This one, a user was asking what is the role of a RESS, and that is an acronym that we use inside of NVIDIA, but the initial implementation of the agent was hallucinating the meaning of that RESS, and the issue there was that there was a query rephrasal error in the pipeline. The second type of error is where the users were just asking how many days does NVIDIA provide in Canada, and the router at the top of the agent was routing the request to a wrong expert inside of the application. And so what the team did is essentially they did a comprehensive analysis of all of the different thumbs down and negative feedback that we had gotten and decided to prioritize 2 choke points on the agent to focus on optimizing the agent moving forward. And at that point, and here's some takeaways on how to better do error attribution. I talked about a few of these. The biggest thing that I would say here is you want to help your subject matter experts automate as much of the classification as possible. But now we're going to talk about probably the most important things and where I want to focus the majority of the time, which is planning improvements and executing the improvements. And this is where the data flywheel comes along. So how do we think you can keep these agents constantly fresh and constantly learning? The key is you have to be able to leverage the proprietary data that exists inside of your organization. This proprietary data can be very much the logs that we were talking about, the completions, the feedback, but it could also be annotated data sets that you have inside, PDFs, it could be also synthetically generated data sets. And this flywheel that you see here is essentially the different steps that you will need to use, that you will need to go through to be able to leverage that data. The data doesn't come perfectly formatted for fine-tuning or in context learning. You will have to process it. Then you will have to do some model customization. That means that you will have to either fine-tune it, supervise fine-tune it, or you can use RL if you need. And then you'll have to evaluate the model, and then we have this whole inference loop. So what we have created at NVIDIA, and this is like my only mini pitch part of the presentation, we have created a family of microservices that are dedicated to help the different parts of this data flywheel for enterprise developers. And this is precisely what our developers inside of NVIDIA use to create this data flywheel for their agents. So Nemo Curator is essentially a microservice that allows you to do things like lexical deduplication, semantic deduplication, classification, to be able to very expeditiously process all of the data that you have in the enterprise and format it so that it can be used for customization. Nemo Customizer is essentially an API that gives you access to a number of customization algorithms like PEFT, SFT, DPO, and GRPO. Nemo Evaluator is evaluation benchmark, the evaluation framework that allows you to do things like evaluating against academic benchmarks, proprietary metrics, LLM as judge. And the second part of the loop is essentially the guardrailing mechanism that allows you to have safe inference, like things like PII detection and PII removal. And then Nemo Retriever is just embedding and re-ranking models to be able to provide the right context at runtime. That was a mouthful. And what I wanted to say is when the team reached out to us for the original agent, what we did is we ended up building this data flywheel with these microservices that are modular in nature. And what we started doing is we started collecting all of that feedback that was coming through the agent, and we started passing it through the pipeline to curate it, help a subject matter expert review all of that data and create customization sets so that they could do fine-tuning of the different modules that we identified. And the two primary tasks that they asked us to help them with was the router errors and the query rephrasal errors, which were the two big clusters that they encountered that they were having troubles with. So what does that experience more or less look like? And again, this is just an internal tool that we built for NVIDIA developers, but anybody who's building applications, like for example, Weights and Biases, who are some of our partners, or other applications in the industry, they can use these microservices as primitives. And in here, the subject matter expert just had access to all of those logs and all of those completions that were being generated by the agent. They could go in and annotate them, filter that list, identify the pieces of content that they wanted to annotate, and then save them into a data set. And once they've created those data sets for customization, they can very quickly run fine-tuning jobs like PEFT or SFT, get the training loss curves, and determine whether the experiments were accurate or not. Okay, now we're going to get to the most exciting part of the presentation, which is, does this thing actually really work? Can you show us real examples of flywheels that have worked for you? And I'm going to share two types of experiments that we ran for this team. So let's talk about some of the experiments. The first experiment is, as you remember, the router is at the top. They were encountering router issues. So we collected a bunch of data. Subject matter expert helped us validate that data, curate that data, and we ended up with 685 examples after removing duplicates, and we created a 60-40 train versus test data set for customization. The baseline performance of that router was actually significant. It was quite performant, and in fact, it was using a fairly large model. It was a Llama 3.1 70B running on 3 GPUs. So we were a little bit concerned when they showed us these results at first. They're like, hey, can you improve this? And we said, I don't know if we can improve the accuracy that significantly, but we can certainly try to optimize the performance of the agent by reducing latency and the cost of like running a massive model for this very specific task. So we started with very small models, a 1B, a 3B, and an 8B. And you can see that when we just moved the prompt, the baseline performance of these models was really poor. But once we implemented the data flywheel and we started collecting the feedback and fine-tuning with LoRa adapters, you can see that all of the models start converging towards the performance of the 70B. So at the end of that result, the team was able to essentially migrate from a 70B model that was using 3 GPUs for a single model that was running on 1 GPU, lowering latency by 70%, and we were able to match the performance that they were getting with the 70B. The second error type that we tried to address was the query rephrasal error that I showcased at the beginning. And in this case, again, we collected a bunch of data. It was manually scrubbed. We identified great examples of where query rewriting wasn't working, and then we used synthetic data generation to create a much broader sample size, up to 5,000 samples that we then split into training, test, and validation sets to fine-tune the models. And again, the results were as follows. In this case, we were actually able to increase the accuracy of a much smaller model by like around 4%. We were able to lower the latency by 40%, and they were able to move from a 3 GPU model to a single GPU model so that the total cost of ownership of the agent was reduced. So now, if we go back to the original examples of the issues that they raised to us, after the fine-tuning and the data flywheel was implemented, the agent was able to correctly resolve using the rephrasal error, because now it's been fine-tuned and the router started performing better and is able to choose the right experts. So to summarize the conversation, This is a framework that we suggest that you implement as you're trying to build these agents so that they can continuously learn. It's called MAPE. You should monitor user feedback. You should create intuitive user experiences, collect implicit signals, get balanced feedback. Second thing is you should analyze and attribute all of that data so that you can RCA, plan the improvements. You don't always need to necessarily do fine-tuning. You can do prompt engineering. You can do all sorts of other customizations. But the idea is that you continuously optimize and test those hypotheses in your system. And then you should roll out those improvements in a scientific manner and run experiments, make sure that you have the right eval sets, and get the value. So now this is your opportunity to build these data flywheels. We have actually created a sample, a blueprint of this very specific experiment that we just run with our partners at Weights and Biases. Here's a sample architecture of what this data flywheel looks like. We will provision a sample customer success agent at the top, and you will be able to deploy these microservices. And what will happen is the agent will simulate usage, and we will be able to collect logs as the agent is being run, and we will autonomously fine-tune the routing agent or the tool calling model inside of the agent until we find a candidate from a set of candidates so that you can showcase how to run a data flywheel inside of your organization. You can do all of the observability through Weights and Biases Weave and Weights and Biases Model Dashboard, where you can see all of the results of the fine-tuning experiments. And if you would like to try this out and try to get a data flywheel going, you can essentially download it from there. And I finished 2 minutes earlier, so if you guys have any questions or comments, happy to take them on. Yes, sir. So this was, yeah, you saw like how this was, first of all, he's asking, why did you focus on 2 error types that only account for 7%? That 7% was just from a sample of 400 iterations, but the challenging part of those 2 errors is that they happen at the very top of the tree. So if you route incorrectly a request, it doesn't matter what happens in the rest of the inference, you're going to get wrong. And similarly, like the secondary step after the query after the routing is that once the request has been routed to an expert or combination of experts, it has to be rewritten so that the retrieval pipeline can accurately retrieve the content. So the team decided to pick those 2 because they are sort of like critical bottlenecks in the system that if they fail, everything else downstream fails. And so we were happy to oblige in helping them try to solve those 2 problems.
Any more questions? Yeah, let's just use the mic for everyone else in the room.
Hi, thanks for the talk.
Yep.
My question is specifically about the Nemo classifier. What sort of classifiers did you use? Did you use an LLM? And secondly, did you ever consider using that as perhaps a reward function to maybe do something like GRPO or something?
That's great. So we haven't, for this specific use case, we haven't done any type of reinforcement learning. Nemo Customizer, the microservice that enables you to do customization of models, does support DPO and will be supporting GRPO. For this specific use case, we did not attempt. I think that's a great idea to do that. And in terms of the classifiers for error classification, the Nemo Curator microservice comes with a variety of BERT models that allow you to do different tasks of data processing. There's also some custom classifiers that you can specify in the model. I think moving forward, probably people will be experimenting more with RL, but for this specific use case, we did not do it. I think it's a great idea.
Wonderful. I think that's all the time we have for questions, but please, another round of applause for Santiago. Thank you, Santiago.